we have a problem. You can find it at Leetcode 1857. Problem number 1857. So the problem is you have a few nodes. Let's number those nodes as 0, 1, 2, 3, 4. You can have many nodes, but for the sake of explanation, I'm taking 5 nodes. And they are colored. You can have 26 colors, and each of those colors are labeled using a small letter English character. So A, B, A, C, A. These are the colors assigned to all these nodes. Here 0, 2 and 4 have same color, which is A. And you will be given an edge list. 0 is connected to 2, 2 is connected to 3, 3 is connected to 4, and 0 is connected to 1. 1, 2, 3, 4. 4 links. The problem is now you have colors. Here it is A, 1, it is B, for 2 it is A, for 3 it is C, for 4 it is A. Here you have 2 paths. If you are starting, this is a kind of DAG, directed acyclic graph. So you can consider 0 as starting point. Some node which does not have any incoming links. So it will act as a kind of starting node. So if you consider that way, you will have 2 paths. One path will be this, the second path will be this. So in your first path, if you check, A is the color which repeats maximum times. A repeats 3 times. And in the second path, A and B are there, both are repeating 1 time. So the color with maximum frequency, you have multiple paths. In each of those paths, you have to identify the color with maximum frequency. This path have maximum frequency 3, this path have maximum frequency 1. Whether it is A or B, it doesn't matter. You have to find the maximum frequency of the color in a path, and out of all the paths, you have to return which one is the highest maximum frequency color, which will be present in every from among every paths. This is a problem. So how will you proceed with this problem? This is a advanced hard problem. So I guess you will be having some idea about the basics. So how a topological sort works, what are the fundamentals of dynamic programming. If you have that, listening to this video will be worthful, or have that fundamentals and revisit and watch this video. So how will you proceed with this problem is like, you need to create this graph obviously. Then you need to create an in-degree vector where the 0th node will have in degree 0, 2 will have 1, 3 will have 1, 4 will have 1, and 1 will have 1. And you need to start exploring with the breadth-first search. So you will be starting from here. You will be propagating in your second breadth towards 2 and 1 in your second level of breadth-first search. In third level, you will be here. Fourth level, you will be here. So this is the way you propagate your breadth-first search. So when you propagate your breadth-first search, the initial nodes, it will have a color. It will be one among the 26 colors. So you will have a palette for every node. You will have a palette representing 26 colors. This will have 26 colors, and the frequency. See, you reached at this node from nowhere. So the frequency, when you create a frequency map of color for this node, you will have only one of them set as 1, the color of this 0th node. When you go to 2, suppose there were a third node, there were a 6th node, which is numbered 5. It will have some color palette. And you have 0th node here. It has a color palette. So you will have to compare the color palettes of both while updating the color palette of number 2. Color vector of the number 2. So color vector will be like, this will be one path, this will be another incoming path to your vector node 2. So which path is, you have 26 colors, you have 2 paths. you have two paths. So which for each color, one of the path will be contributing some, either it will be equal or it will be unequal. In case of unequal, you have to choose the best value among those two. So when you propagate your topological sort, whenever you land from a node to another node, you have to update your target palette using your palette at the origin. That way, you will be able to populate the palettes of every node. The palette or vector will be having 26 colors, each of which with its frequency, in that each of the cell will be having a frequency which will be representing the highest frequency from all paths, highest frequency from all possible paths which are landing at that node. That's the idea behind solving this problem. So once you have all the palette, all the vector, whenever you will be enqueuing and dequeuing. Whenever you dequeue this node from your topological sort queue, you can compute the maximum among that 26 colors and keep that as your answer. You can continuously update your answer. You can take your highest value among them as your answer. And this is one way. This is the one concern of this problem. And the second concern is, what if you have some kind of edges, cycles? 2 is connected to 3, and what if 3 is connecting back to 2? This case is like, if you really wanted to explore 2, you have to relax all the incoming nodes of 2. So you will be initially enqueued 0. So when you enqueue 0, you will be initially enqueued 0. When you enqueued 0, when you explore that 0, you will be relaxing this node and this node. Then you will be enqueuing 1. But you will never be able to enqueue 2 until you relax this node. So that way you will be missing the entire trajectories which are belong to this area. So if there is a cycle, the number of nodes you will be visiting will be less than the number of nodes you will be having. Number of nodes visited will be less than number of nodes available. You can keep a counter for this. You can check before you return this answer. If this check is failing, you have to return answer as -1, because you haven't explored all the paths available in your system. Let's see the code that will give you more clarity. So you have your color scheme and the edges. Let's create a in degree vector. Number of nodes will be like, this is the number of nodes. Create a degree vector of n nodes, mark it as 0. Then create a graph of n nodes. Now you want to populate the adjacency list. So it's edges. Grid of IT0 is connected to IT1, and increment the degree of that target node of the edge. Now you need a queue which will be having an integer, and you have to enqueue elements which you will be exploring first. So it will be like I equal to 0, I less than n, I plus plus. So you have to check if the degree is 0. Degree is 0, enqueue that node. And same time, you need your color palettes for each of the node. This will be a 2-dimensional vector. It will be a kind of DP vector. So you have n nodes and 26 characters, 26 colors. Size is initialized to 0. When you are enqueuing it, you have to mark the length of their colors as 1. Length of node's color as 1. So dp of I, the color will be colors of I minus A. This will be 1. Now you can start doing breadth first search. Meantime, you can have your answer vector initialized to 0. Pop the element out of the queue. Get from the palette which color have highest frequency. Get that color. You are exploring that X which were there in front of the queue. So get the highest frequency and update your answer with that frequency. This will be dp of I dot begin. It's not I, X. P of X dot. The answer will be max of X. Now you have to explore the neighboring edges. They are grid. Update your color vector. Your color vector of your target. So it will be dp of next of I is equal to max. dp next of I, comma, dp of origin of I plus if your target vector has same color as of I, then increment by 1. So how will you plus of next minus A. So now you updated your target color palette or vector. Now reduce the degree by 1. Degree of next by 1. If it is 0, enqueue the next. To check whether cycle is there or not, you have to decrement the counter of seen elements by 1 every time when you explore a node. Now finally, before you return the answer, check seen equal to 0. Seen equal to 0, then return your answer, otherwise return minus. Let's test the code. It gave you 3. You have 0 with color A, 2 with color A, and 4 with color A. So the answer is 3. Previously calculated, the answer is. Thanks for listening.